My name is Mark Holbrook. I am the adjunct professor here at the College of Engineering at Idaho State University. I have an extensive history of a work environment at the Idaho National Laboratory for 40 years. The crucial portion of the motor operated valve question goes back to the 1980s, and it's vitally important that we be able to take the information that we learned from this engineering project that was conducted all throughout the 1990s in the industry and be able to transfer that information to people who are working in the industry today. And the question all relates to the safety-related performance of motor-operated valves under highly loaded accident conditions, because these valves spend most of their lives sitting in the plant ready to act if an accident occurs, and they have very little opportunity to demonstrate their capability. So we developed a program in the 1990s to be able to demonstrate that these MOVs will perform under design basis conditions, which is crucial for the performance of plants when it comes to public safety, ensuring that our plants are running reliably and safely. But now here we are in 2024, and we have new people working in these departments that care for these motor operated valves, and they weren't around when we learned all these lessons back in the 1990s.
Hi, my name is Ganu Kim, and I'm from South Korea. And I'm working in KINS, which is the Korean Regulatory Institute of Nuclear Safety. I'm here to learn the MOV performance evaluation and also the regulation in the US.
Hello, my name is Rita. I'm taking the MOV Design Basis course. I'm from Illinois and I work for Constellation. I chose to take the course because it was heavily recommended by a lot of my peers, like in the MOV world. They had taken it before and they told me that it would really help me understand things better. Sometimes you can know what you're doing, but you don't necessarily know why you're doing it, and it can make retaining the information a lot easier.
Kevin DeWall, my fellow instructor, and myself, we've seen this effort materialize throughout all of the 1990s up to the present. So we have that knowledge that we're able to transfer to new students that come in from the utilities. So it's a knowledge transfer activity that we're providing, or service we're providing to the nuclear industry.
My favorite part of the class was the lab portion, because we got to see an MOV, and we got to take apart an actuator, and we fully got to see an MOV test.
In here, I can see the valves or other parts in eye to eye, so it was very interesting.
And we also want to focus this class on the engineering aspects and not so much on the nuts and bolts issues with how these MOVs come together and how they're disassembled.
I think it is very helpful. This class is very helpful for regulators or engineers in the nuclear industry or other industries, because this course is it covers details about the MOV.
And I would recommend this course for other students because I've been in my position for 6 months, so things haven't, you learn a lot about code. It's always very theory-based, so I would recommend it because I genuinely feel like you learn as to why a lot of the codes you are reading about, why they were implemented.
We really want to be able to provide the why. This is an important topic, and why these valves need to be able to operate under design basis conditions, and how we look at all the performance parameters that come together to show and demonstrate to the public that these valves are going to function under an accident condition and that our plants are safe as we say that they are.
I recommend you to learn this course.
Yeah, I think it's a great time, and you learn a lot and you walk out a better MOV engineer.